Welcome to the first podcast of our second season of the Enabling Automation series, where we bring experts from across the ATS group of machine builders to provide insight to those looking to implement automation within their organizations. First, we're extremely thankful that we have a second season, and there's really two groups to thank for that. First, the team behind the scenes at Enabling Automation that make this podcast come to life. Thank you for all your hard work. But most importantly, thank you to those who are listening. Without you, we wouldn't have the opportunity to continue this podcast series and continue to provide insight into the automation market. Now, let's get to our first episode. I'm excited to start at the beginning, where the topic of today's discussion is the foundation of the automation solution. First, I'm your host, Simon Drexler. I'm the general manager of the products group inside of ATS, where we look to standardize solutions across machine builders doing a variety of things across a variety of industries. I've been in the automation world in a variety of roles, both startups and large companies, for approximately 15 years. And today we're joined by Ben Hope. Ben, can you introduce yourself to our listeners?
Hi, Simon. Thanks for having me. My name is Ben Hope. I am the Director of Product Commercialization here at ATS. My career in automation stretches all the way back to 1997, which I don't often like to admit. At the time, I was in high school and I was looking for what I was going to do with my life. An opportunity came up to work part-time at ATS in the electrical department. So I was interested in that. It gave me an opportunity to kind of see what ATS did. And it gave me an opportunity to think about what manufacturing is, where all the things that we use in our lives, in our everyday lives, come from. And I don't think people consciously think about that. I studied electronic engineering technology at Conestoga College. When I graduated in 2002, I took a job at ATS on the SuperTrack team. At the time, SuperTrack was in its infancy. It was just before we went to market. And my role was really assembly, testing, troubleshooting, support. So today, my role is really about product management, marketing, and business development of SuperTrack. And I think those three kind of functional areas go really well because product management is responsible for understanding the market, what we need, how we measure what we need, feeding that into marketing and communicating that to the market on what we're trying to do. And then business development, I look at as kind of the feedback loop. So we can go out into the field, we can talk to customers, we can really develop those relationships and then feed that back into product management.
What a great background where you started and now you're out broadcasting new technologies and new approaches to the market for how we can transform the way that automation is built around the world and across a variety of industries.
Mm-hmm.
Let's jump into it. Great topic for the first episode of season 2. It's the foundation of automation. And many of our listeners are looking at automating for the first time or looking at leveling up the amount of automation inside of their operations or inside of their business. Where would you recommend that they start?
I think the kind of normal way about going about it is always looking at the ROI. And I think traditionally that's how automation really starts. Does it make sense financially? I think we're starting to see a change there, and automation needs to open up a little bit. When it comes to assembly automation specifically, it's very, very customized. Everything is customized. But when you look at the common denominators, we always say it's motion, and motion is the foundation. And if you look at the motion requirements of a lot of operations, picking and placing, screw driving, pressing, those motions could potentially be standardized. And I think looking at how you can standardize on an automation platform and really try to limit the amount of customization that is required. And with customization, I would say it's end-of-arm tooling and things of that nature. Could we have that kind of standard platform that we can apply and really start to reduce the cost? Because the biggest barrier for people new to automation is that cost. And I always find that small companies, startups really look at assembly manually. They'll kind of get people to do it. Big companies use automation. And it's the companies in between who are trying to scale that really struggle because financially it just doesn't make sense. And we've seen technology really kind of advance in leaps and bounds in other industries, software as an example. And I think that same kind of innovation needs to come to automation. And we're starting to see it now because the demand is just starting to skyrocket. We need better ways to access automation. Everything can't be customizable. It can't cost what it costs today. It needs to start coming down, and technology I believe, is the enabler for that.
We certainly share a passion for standardization and a passion for platforms for exactly what you so well articulated. The demand for automation is going up faster than automation can be provided. That's creating a need for a change in approach. For someone that's new, trying to automate for the first time, looking at standard platforms is a way to bring their cost down. Is there an area of the machine or an area of what they're analyzing that you would recommend that they narrow in on?
Yeah, I think it's probably easier said than done. I think it really depends on the product and the process that you're looking at. I think we've seen a big advancement with collaborative robotics helping to solve, let's say, the repetitive assembly tasks at a workbench. You could pull up a collaborative robot, teach it to do that. And sometimes that's sufficient. I think as you get into more complex assemblies, that isn't as easy. And we at SuperTruck really start with conveyance, because the conveyor is what brings the part or the product, whatever you want to call it, through the process. And the efficiency of that is important. So if you start with the conveyance, you can really understand that flow. And then it also enables you to scale, because most hardware manufacturers are looking at output capacity and how that meets their market demand. And they may start with, let's say, an output capacity of X. And then in a few years, they might want to go to 2X, 5X, 10X, et cetera. Traditionally, what that meant was every time you need to scale, you need a new automation system and you need a new solution, which is obviously expensive from not just a material perspective, but it takes 18 months to get an automation system engineered and delivered. And then you need to support all of that. By looking at technology like conveyance as the foundation, you can start to understand the technology, how you can use it, understand how that's going to impact your process and your future process, and then scale on top of that without having to retrain maintenance teams and engineering teams on the technology each time.
So you said a few things that I think are really critical for our listeners to understand. I'm going to use my background in autonomous mobile robots. And if you look at automating a factory with autonomous mobile robots, you care a lot about flow, you care a lot about scale. And those really transcend the type of automation that you're trying to pull in. Those companies that are between being small and being large, those that are looking to scale, those are two things that they should really care about, both flow and scale. Mm-hmm. And by looking at the way that you move parts around, you drive both of those opportunities. You understand your flow and where your bottlenecks are and your ability and capacity to scale. Is that a fair statement?
Yeah, it's dynamic, not static. And I think approaching it that I'm going to spend this money and get this machine running and utilize it in the same way for 20 years is perhaps okay in some industries, but for most industries, particularly those people scaling, it's not really an option. So trying for them to be able to get that ROI calculation to work for them, I think is important. And scaling is really a big way to do that.
Right. And the third thing that you touched on, because I only said flow and scale, but flow and scale and standardization. So if you're looking at a conveyance foundation as your primary standard, does that help people standardize?
I think so. I think once you start standardizing on anything, you start to realize the benefits of what standardization means. And with any kind of technology, the number one kind of biggest barrier is familiarity with the technology, how to use it, what's the best way to apply it. And once you're there, then you can look at things like spare parts. You can look at things like how the operators interact with it and whatnot. And I think that really starts to show the benefits. And you really start to see that on the bottom line. And then taking that to the next level and starting standardizing on other pieces of automation really starts to open up some possibility.
You just touched on something that I think is really important for our listeners. People who are new to technology, new to automation, they're working through understanding things for the first time. When you standardize on a piece of technology, regardless of what that is, your understanding solidifies, and that can really snowball into the organization as a whole. And you mentioned spare parts, you mentioned maintenance, you mentioned operation procedures. Standardizing on a piece of technology, does it also help to accelerate design of automation and implementation of technology?
Absolutely. I think the things you're familiar with are the things that you're comfortable with. And design and conceptualization is where it all begins. And in this business, people want to take the lowest risk path. At the end of the day, like I always like to say, manufacturing is the true definition of B2B. It is only investing in things that are going to help you do what you're trying to do, or it's going to help you make money, et cetera, et cetera. Nobody buys anything in this industry just as a luxury or just because it's cool. And that risk is always managed by your familiarity. So if you don't know how to use something and you have a different path to get there, most people are going to take that different path because it's easier from their perspective. What the biggest barrier is convincing people that technology can provide a lot of benefits and solutions that you may not have necessarily considered. And going through the process of familiarizing yourself with the technology, how to use it, how to engineer with it, how to program it, how to operate it, starts to really reduce those worries, and the risks start to become less. And like everything, it's all about the psychology of that particular person, but getting them comfortable with the technology. And then once they're there, and once they've gone through that experience once, like you said, things start to snowball and people realize the potential and what they can achieve and what they can do. And that's what excites me about this industry.
And ultimately, that's going to improve the business's ROI. If you have familiarity, if you have a comfort level, you're going to be able to create better processes, create better implementation plans, get technology into the business faster. And speed is normally the enemy of ROI.
Yeah, I think if somebody realizes the potential of something and they care about the business that they work for, then they generally want to champion it to help other areas of the business. Hey, I implemented this technology. It went really well. We've been able to do this, and this. It's benefited us here. Our ROI makes sense. You guys should really start looking at it. You should really start seeing on how this can help you. But you need to start here, understand these steps before you can get there. And I think champions within organizations who have a passion for innovation and a passion for making things better, I think are the people that are really going to start to change things and understand that better.
Right. And we get the benefit of talking very often. So I know the answer to this question before our listeners. When we circle back to the foundation of automation process, the foundation of building up equipment, it really does start with conveyance. I believe personally that's the single most impactful choice that we make in system design. Do you agree with that?
Yeah, I think absolutely. It is really the fundamental first layer. It's what, like we talked about, the flow. It brings the product through its assembly process, and it is critical. It's kind of, an analogy might be a city. And if you build the city before you build the roads, then you're not going to have a very efficient city. And I think understanding the route that the product needs to take is something that you're forced to do when you look at conveyance to start. And when you look at what the conveyance is capable of doing, then you can better understand what you need to do to build on top of it. And I think in our experience, when people start with conveyance, they end up at the end of the day with a better automation system in a smaller footprint with better performance. So absolutely, I think conveyance is step one.
Right. And then so if we're equating flow as a means to drive ROI, and there's a lot of overlap with both scale and standardization, but if we standardize on a motion layer, that really helps to start the snowball running for standardized technology, standardized approaches for processing, which really enables our listener companies to scale. Is that in alignment with your thinking?
Yeah, absolutely. I think it becomes a natural process as well, because again, technology is really about getting over the hump of the risk of not being familiar with it. And I think anytime you're standardizing on anything, you again realize how it can help, and that it's not necessarily a huge hurdle. It's something that takes time to understand, but it's not an impassable hurdle, I guess. You can get there, and then you can start to look at other areas of the machine that can also be standardized. Because in my experience with automation, the wheel is reinvented time and time again. And that is money, that's time. And we have to get away from that because things are growing exponentially and people want access to automation. And there's not enough people to continuously customize everything all the time.
I completely agree with you. You've mentioned the word familiarity a few times. And with the understanding that our approach would be that the motion layer is the foundation of the approach, are there tool sets that our listeners could use to better understand material flow to help build their familiarity before the equipment arrives, before diving into the technology?
I think we're really seeing the rise in simulation. So that's kind of a topic that has been talked about for more than 20 years, and it's been hard to actually achieve. But now we're really starting to see hardware emulations and simulation tools that we can go into our computer, and we can kind of look at what we were trying to do and how the technology is going to impact that, and really start building the concept of the digital twin. And I think that's been one of the biggest kind of outputs of Industry 4.0 kind of thought process, is the idea of the digital twin. And the digital twin enables you to conceptualize and simulate better. It enables you to engineer better. And then it also enables you to implement continuous improvement, because you can look at the digital twin, how it's performing, and you can start to apply things to improve it and see how that actually comes out. Did it improve it, or did it make it worse? And it's really expensive to do that in hardware, but it's very, very effective to do that in the digital twin. And I think more and more companies are looking at ways that they can contribute to building the digital twin. And obviously data is important there, but just general engineering tools and almost how we can implement AI to help lead people in the right direction.
Right. And digital twin is sort of one of those general topics. It's like Industry 4.0. It can mean a number of different things to a number of different people.
Yeah.
So for the benefits of our listeners, a digital twin of a full system can be quite complicated to put that together. It might be several weeks or even several months to be able to do it at 90% accuracy or above. Is there a path for someone who's new to automation to use motion simulation or material flow simulation to do something easy or do something straightforward, rather than diving full into, I would say, what the traditional definition of digital twin is?
Yeah, I think a lot of companies are looking at kind of simulation / configuration tools and how they feed into each other, and starting with what you want to do. Traditionally, when you wanted to do anything, you really needed to understand the technology, and then you applied it to the process. Today, we're really starting with the process. What are you looking to do? So from a material flow perspective, what is your output capacity? We're looking to do 60 parts per minute or 100 parts per minute. Okay, that's our starting point. We have a conveyance system. How can we then use this simulation tool to look at how many steps do we have in an assembly process, as an example? How many reject stations do we have? How can we start to look at the flow of the product through each one of those assembly stations? How does that impact our output capacity? We start to see stations being starved, or we start to see stations maybe that are overperforming. There's been too much performance built into it, and you don't really need that. And you can really start to balance the system. And looking at something like that, it's not necessarily having to be an expert in the technology. It's understanding your process. And getting back to the original question of entry into automation, you got to know your process. Automation is only going to be effective if you know your process. And the simulation tools of a conveyance system, for example, can really help you optimize that process.
And for those who haven't done this before, like, how long would it take to put together a motion or a flow simulation after you have a decent understanding of your process, a decent understanding of what you're trying to automate? Like, is this a hard thing to do?
To get something running, it's not a hard thing to do at all. I think with our own tools, it's something that you could kind of get moving in 20 minutes. I think the fine tuning and the optimization is something that can take a little bit more time and may take a little bit more insight from people, because if you do need to look at how many parts in a station you're working on, or how you're utilizing the shuttle within that station, that can take some time to really optimize. But again, the tool is really showing you the path and showing you the impact of your decisions. And rather than changing a whole bunch of variables and not being able to really measure the impact of those, you can kind of change one thing at a time and say, okay, if I did this, well, what does that look like on my output capacity? It's like, okay, that's an improvement. And you can really build that in a constructive and real way.
So within 20 minutes, you have baseline, and then you can start the optimization path, which the iteration of that would really help with the understanding of the process anyway. Like, you're using a tool set that exists, very rapid deployment to get an understanding of what future state looks like, but help with your iteration of current state as well.
Absolutely. Yeah.
Wow. And so for those that have experience with digital twin, like, normally on an automated system, that something like that could take 4 to 6 weeks worth of dedicated effort to put together for the whole system. But we're talking half an hour or less when you focus in on that foundational motion layer, that conveyance layer.
Yeah. And anyone who's ever kind of been involved in the engineering phase of automation, I think can really appreciate how effective and efficient that can make their jobs.
You just touched on something that I care a lot about, but in a completely different way, to be honest. We arrived at it through material flow, and using your motion or your conveyance simulation can actually be a proxy for your entire process. And so for those listening, why is motion the foundation, or why would a conveyance approach be the foundation of an automation solution, is because it can be both a proxy for how the complete system works upon full implementation, but also because it illustrates your critical understanding of your process and where the bottlenecks are.
Exactly. And I think anyone who's ever designed or engineered anything, you encounter those holy crap situations. I didn't think of that. And simulation really, really highlights that and shows you, okay, the process is moving, but we're starving station 2. Why are we starving station 2? It's taking too long. So maybe we can look at working on more than one part in station 2. Station 3 is doing pretty good. We're currently working on 3 parts. Maybe we only need to work on 2 parts. And it really just starts to help you fine tune and understand what you're doing.
And I guess the interesting thing about that, for, again, those looking to either step change automation or get into automation for the first time, is that you don't necessarily need to know exactly how the processes work at the stops, right? You just need to know how long it's going to be there. And then the motion or the flow simulation can show you where your problems are.
Yeah, exactly. You have a pick and place operation. It takes 2 seconds. In a simulation of a conveyance system, the shuttle comes into station, and then you have a 2-second delay. So you can just understand that process flow. And then once you've understood that, you know what your system performance is going to look like from a high level, that bird's eye view. And then you can start focusing on the stations. So this station takes 2 seconds. Station 2 takes 2.5 seconds. We need that to be 2.3 seconds. And really starting to kind of engage that to get you where you want, so that you're balancing the whole system. Because ideally, if you want consistent output, you need each station working in balance. And you don't want anything starved. You don't want anything overperforming. You want that real nice balance. And the simulation tool is the way to achieve that very, very nicely.
Yeah, you're touching on some really critical pieces for those listening, because to get the ROI for the implementation of technology, you need to focus on your output. And if you're looking at a tool that provides you flow through your process, regardless of your cycle time is 2 seconds or 2 minutes or 2 hours, wherever the bottleneck is, that's preventing you from getting the output you need to drive your ROI. And so if you have a tool set that's monitoring your flow and showing you how your process is going to work, then you're building up your case, your ROI. You're building up your system design by highlighting where your challenge areas are.
Yeah, it's just another resource, or that you can use to show management that here's my ROI. This is how I've calculated, but this is what the system's going to look like. This is why this ROI makes sense. I can show you this in the simulation tool. I think that goes a long way, because traditionally, again, you're really looking at spreadsheets. You're not looking at how the machine is going to work. So you can assume best cases and you can assume this and that, but to be able to really show what you're trying to do, I think goes a long way.
I think that's another thing that sort of fits into the familiarity bucket, which is it's an interesting portion of the conversation, because a lot of implementation of the new technology is not only the design or the understanding of what we're trying to do, it's communicating that across all the stakeholders of what you're trying to do. And so simulation and even a motion proxy, like just looking at motion flow, if you actually have a visualization rather than a spreadsheet, it drives the picture home of what future state looks like better than.
Yeah, exactly. I like that. It's the light bulb turning on for people as a way to really understand what you're trying to do. Because again, new technology is a risk to people. That's how they view it. And anything that you can use to communicate and show them why it's not as big of a risk as you think, that's more of a subjective problem than an objective problem. And I think communication is a way to really achieve that.
Right.
So, yeah, I agree.
It's a risk. It's a change. Anytime we're trying to drive change, there's always resistance to it. So Absolutely. If you have a better tool set, if you have better pictures, if you have better visualizations, you have more arrows in your quiver or tools in your toolbox to be able to communicate with a broad set of stakeholders.
Absolutely.
Interesting. And so I think that really actually sums up quite well why motion and part conveyance is the foundation of automation. You have this layer that touches all the processing stations. You have this layer that you can use as a proxy for both your your flow or process understanding, but also an illustration of what the future state could look like by focusing on one component, one standard.
Mm-hmm. Yeah, absolutely. And also how much space you're going to take up on the factory floor, which management is also looking at. They want the smallest amount of space with the maximum amount of productivity. And simulation tools can really help you fine tune that. So you're looking at the process and how much space you're going to take up. So being able to go into your boss and say, hey, this system, I'm going to be able to get this output capacity. It's going to take up this much space, and we're going to use this technology, and we are going to build this awesome automation system. And we have a lot more confidence than we have in the past because we're using these tools before we necessarily go into the kind of main phase of engineering. And it gives people that insight and that confidence that we can actually achieve what we're trying to achieve rather than just hoping to achieve that.
Ben, I think you've done a great job of explaining to our listener base why the conveyance layer, the part motion layer, is the foundation of automation. It's the area you should start with. It helps in two critical areas: understanding of process, as well as understanding of what the final technology implementation might look like. It helps build that case. It helps to communicate. Any closing thoughts that you want to leave the listener base with?
The idea of automation, industrial automation, has been reserved for really the big corporations that can afford to really implement automation. And I think we're starting to really see a change there. I always compare automation to the idea of the software world. And back in the 1980s, if you wanted to write a piece of software, you needed to know everything from device drivers, how the software interacted with the hardware, all the way up to the application layer. And it was really a specialized group of people that could produce software like that. Today, you can use multiple different tools. You can do apps. You don't really need to be an expert to create software anymore. And that's really opened up everything that we've seen today from a high technology standpoint. And I think that same principle needs to be applied to automation. We got to stop reinventing the wheel every time. We got to start agreeing on standardization. And that's going to really open up the potential for more people to get involved. It'll start to bring down costs, and it will start to resolve a lot of the issues that we're currently struggling with. The idea of low-cost manufacturing countries has been the solution since probably the mid-90s, and we're starting to see that for a lot of reasons, that's not kind of the best path anymore. So how do we still make things and still make them cost-effective enough that people want to buy them? And I think automation is the way to achieve that. So bringing automation closer to the consumer, I think, is critical. And the only way that's going to happen is if we have the adoption of technology and the agreement that standardization is important. Rather than competing and trying to get different technologies that do the same thing, I think companies need to start looking at, if we standardize on this, it's going to enable us to do all of these other things and really open the market. And I think that prospect is exciting for me and where we could take that. So I believe the next 10 years will be really, really exciting to be in the automation space. So I think that's probably where I sit on that.
It's great, Ben. Thank you very much for joining the podcast today.
Yeah, thanks for having me.
I feel very fortunate to be able to work closely with you, and I can't wait to see the transformation that you're able to drive over the next 10 years of this very important time in the automation world.
Yeah, very cool. Thanks for having me. Nice chat.
For those listening, thank you very much for joining us today. I hope you enjoyed the episode. If you did, we are continuing our second season with episode 2 of how automation affects your supply chain, which is an interesting topic for me because normally when we're talking about automation, we focus so much on the technology. We don't necessarily talk openly about the supporting functions and the impact that automation has on them. So we're being joined by one of the executives inside the ATS group to have a discussion about how specifically automation affects your supply chain. So once again, thank you for joining us today. And I look forward to seeing you again in our next episode.